Hello friends, I am Gaurav Murghare from the Department of Electronics and Communication, Oriental Institute of Science and Technology. Today I am going to give a brief introduction about the microwave engineering. So what are the microwaves? Microwaves are the form of electromagnetic radiations with the wavelength ranging from about 1 meter to 1 millimeter with the frequency of 300 MHz to 300 GHz. As we all know, our spectrum is from hertz to the exahertz. That means from the ultra high frequency to the exahertz gamma frequencies. In this, the microwaves are ranging from the 300 megahertz to 300 gigahertz. In the coming slides, I am going to show on the tabular chart what are the different frequencies and what are their wavelengths and further on. From the different sources, and we define the different frequency ranges as the microwave. But normally the frequencies which are having the wavelength from meter to millimeter ranges, those are termed as the microwave. Different books and the different journals will show the different ranges of microwave, but yes, we can limit to one frequency from our. A more common definition in the radio engineering is the range between 1 to 100 gigahertz. That means the wavelength from zero point 0.3 meter to zero point 0.3 mm. In all the cases, microwaves include the entire super high frequency band, that is from 3 to 30 gigahertz. Frequencies in the microwave ranges are offered range by the IEEE standard, and these designated bands are SCX, KU, K, KA, and several other bands are also designed by some other standard organizations. So how this prefix microwave is added to the wavelength? It's just the simple thing. The micro is added to the wavelength. Micro means micrometer 10 to the power minus 3. So whatever the value, that means if any signal is having a very smaller wavelength, then it is termed as the microwave. And if we are using those waves for the communication, that we termed as the microwave technologies. The ranges of the microwave can be termed out from the infrared, terahertz, radiation microwaves and ultra high frequency, but those are not the microwaves. We can easily discuss in our next slide how and what range of frequencies are termed as original microwaves. Microwaves travel in the line of sight, as those are having very less wavelength but higher frequency, so they can penetrate from any of these surfaces, even from the earth surface, from the ground reflections and the reflection from the ionosphere. Only things any radio wave cannot travel through the ground plane, that means which is having the zero potential, so it cannot propagate the ground. Any of the wave cannot propagate the ground. So the terrestrial microwave links are limited by the visual horizon of about 40 miles. That means if on the ground we communicate through the microwave communication, then it can travel only up to the 40 miles, because due to the curvature of the earth, after 40 miles it is difficult to locate the transmitter, and the receiver or the signals won't be able to see directly or not in the line of sight. So as you see in this next slide, a microwave spectrum. We have given different class, their names, what are the frequency ranges, what are the wavelength, and what amount of energy they hold. So we are starting from the higher frequency signals. That means the ionized radiation. These are the gamma rays, hard X-rays, soft X-rays and extreme ultraviolet rays. These are having the frequency of 300, that means gamma rays is having the frequency of 300 exahertz. E means exa, 10 to the power 18. Its wavelength is very low. As we all know, the wavelength is calculated by 1 upon f. So if frequency is this much, that means 1 upon 300 into 10 raised to the power 18, that it will comes out to be 1 picometer, that means the 10 to the power minus 12. It holding an huge amount of energy, that means 1.24 mega electron volt. It is very large amount of energy, that's why we termed as the gamma rays as very harmful radiation for us. Similarly, the X-rays, this is also having the range of 300 to 3 exahertz. And these are having the also the wavelength in the picometer. They also hold the energy of about kilo electron volt. Now the soft X-rays, similarly the ultraviolet ranges from 30 petahertz. Petahertz is 10 to the power 15, and the wavelength for this is 10 nanometer. Nanometer means 10 to the power minus 9. It is also holding the energy of 124 electron volt. After that, the visible range. Visible range, that means near ultraviolet, infrared, mid infrared and far infrared. These are having the frequency ranges from 300 gigahertz to 3 petahertz. Our next range is the ultra low frequency. Before going to this, the microwave ranges or the radio waves are having the frequencies from extra high frequency, super high frequency, ultra high frequency, very high frequency, medium frequency, low frequency and very low frequency. So if we termed out as the microwave, that yes, we can say from 3 gigahertz to 30 gigahertz, or we can also say from 300 megahertz to 30 gigahertz is our microwave ranges. That means from ultra high frequency to extreme high frequency. They are having the wavelength in meters, centimeter and the decimeters. They are holding the very less amount of electron volt, that means 10 to the power minus 6 electron volt of energy. That is also a sufficient amount of energy for the energy transmissions. So these are the microwave ranges. That means microwave, again I am repeating it, microwave ranges from ultra high frequency to extra high frequencies. And the radio frequency from very low frequency to the very high frequency, that means from 3 kilohertz to 30 megahertz. There are also very low frequency components are also there, that means which are having the wavelength of kilometer, but these are very low. We won't use these for communication. So the microwave spectrum on the graphically, if we'll see, these are the visible spectrum from red to violet. So it is clearly visible, that means from radio wave, microwave, infrared, visible, ultraviolet, X-ray, gamma rays. These are all comes under the microwave spectrum. So here in our subject we'll be going to discuss about the microwave. So what are the microwave bands? Microwave bands are designated in LSCX, KU, K and Ka band. So these are the frequency bands and their wavelength. You can go through it. Normally the KU band is using in the satellite communication. All the bands are having the different applications. After Ka band, if you see, Q and U band, these are the millimeter waves. That means we can the signals which are having the wavelength lesser than the microwave, then we termed those waves as the millimeter waves. So these bands, that means V, W, F, D, these are the millimeter bands. So what are the advantages of the microwave? So advantages of the microwave are they are having the large bandwidths. That means we can use from the communication, as the normally the radio frequency ranges are very congested. So these are having the gigahertz of frequency. So available bandwidth is very good. That's why we can use the microwave. As the frequency is higher, so they had the very better directivity. It requires a very less amount of power consumption, small antenna size, and the fading effect is also small in that. The applications we can use in the communication, remote sensing, heating and the medical science. So normal communication which are going in the present day is under the microwave. The ranges are mentioned in the slides. For the remote sensing we can also use for the heating purpose, and the last we can also use in the medical science also. So thank you for joining the lecture.